All right, so we are rapid application development. It says lesson 12, which is where we are. We're doing object-oriented programming today. We'll do this first, and then we'll talk about some assignment stuff later on. So this is probably a good foundational lesson, I would say, for what you guys are doing, and not just in C#, but in other languages as well. Some of it's going to be review, because some of you are very comfortable with object orientation and the whole framework, as opposed to and best practices, as opposed to doing a procedural kind of using procedural programming style, which is a little bit simpler. But when it comes to big programs and more complex problems, it's better to use object-oriented methodology. So we're going to talk about, let's talk about some object-oriented terminology for C#. We're going to talk about that a little bit today. We're going to be talking about two-tier and multi-tier applications. A little bit about, I'm going to mention MVC pattern in there as well. I know you guys are doing that in your other class, but we're going to talk about it a little bit as well. And we're going to get right into classes, the syntax around classes for C# and within Visual Studio, as well as at the end we're going to really focus on visual inheritance, which is using classes, but using the form class as a base class while we inherit controls from, let's say, forms we've built from before, so to save us time, right? And there's some quirkiness around it, because there's some good things about using visual inheritance and some weird stuff as well that we'll kind of go over. So let's talk about this a little bit. Again, objects, right? They have properties and methods. They generate events that you can respond to or ignore, right? And object-oriented programming is, like it says here, probably a very, I would say, accepted style of programming. VB originally was not, as I'm just going to go back to VB for a second, was not object-oriented from the get-go. It's kind of started off as a procedural language. In fact, if anything, was like, I remember the original, BASIC itself, going back to BASIC, and I don't know if you guys, any of you have ever done real BASIC, like in the beginnings, before it was visual, before there was drag and drop. It was, we used go-to statements, right? It was bad. It was like, we didn't even use functions. And then, of course, over time, over a series of years, that all disappeared, and then they started, using best practices. So things that are built object-oriented from the get-go, Java, C# for sure. It says Smalltalk here, but there's other languages as well. Objective-C, which is kind of a derivative of other languages, right? As well as Python. I think Python is a nice example of an object-oriented language from the get-go, from the ground up. Very simple to use and learn. Most languages these days involve object orientation, even if they're not object-oriented. Like, for example, JavaScript doesn't really have, it's not really an object-oriented language, but it does have prototypes, which are very similar, and we've talked about them, I'm sure, in your advanced web programming class. So, so JavaScript is there. PHP, of course, has that uses that whole framework, which is good. So when we build more complex objects, and try and handle bigger problems, this is the way to go. Let's see why. So again, C# again allows you to create objects by creating a class, right? And we've seen already, we've been using them throughout this semester. We've been using our classes, built-in classes, so far, and of course they have properties and methods and events. They handle events, and we've kind of gone over how to define accessor properties, getters and setters. We've already kind of done that for the form class. So we can kind of use that going forward. You're going to see some of that today as well. We're going to talk about getters and setters. And actually most object-oriented methodology, when you learn about object orientation, it doesn't matter which language, like whether you're using C# or C++ or whatever is out there. And again, C++ was not object-oriented from the get-go. It was procedural and a little bit ugly, actually, when it first started off. And then it became object-oriented because that was the mode, right? And there's good reasons for it. So again, we have objects, and what we do is we create instances of the objects, almost like the object. The button is a class in this example, and the exit button is an instance of the class. We've created an exit button. We can create multiple buttons, and each of those buttons are going to be instances of the button class. Okay. So again, it's like it says here. When we define our own class, we're kind of creating a new tool to use when we're programming, right? So it's not just creating a class that we're going to use just for as a container, but more of a blueprint for us to solve our problem a little better and with less code. That's what it's supposed to reduce the amount of code that we use when we use a class. Sometimes it's also around functionality. It gives us the ability to perform different functions that aren't available to us with our standard classes that we have. So here's the cookie analogy, just as a real refresher. So imagine if you're making the class as a cookie cutter. Your object itself, right, is the cookie, right? When you instantiate, you make a cookie using the cookie cutter, right? You make a cookie, and then when every instance is a newly made cookie. So every time I'm instantiating, I'm actually making the cookie. I like the transporter thing better. I still think I'm going to change this one day, these slides, to say your teleporter, and the pattern buffer. But for now, this is kind of a very clear one. The properties are, for example, if you're, the kind of flavor you might have, cookie flavor or the cooking icing, and then you're gonna make them if it's iced or not. If the flavor is lemon, as an example, the methods allow you to do different things with the cookie. They're the action or behavior around the class. So you want to eat the cookie, you want to bake the cookie, you want to crumble the cookie. And the events are when the cookie crumbles or when it's eaten, as an example, then you respond to these events, right? So again, kind of very straightforward. I've also liked the car, the car analogy. There's many other things, the house analogy that you might hear. But more or less, if I was going to give it in a nutshell, when you think about, objects and classes, class is your blueprint, right? Your object is the result of the blueprint. When you're instantiating the class, you're taking the blueprint and you're starting to build the object, right? And when the instance is the actual object that's been built from the blueprint after it's been instantiated. Right? Lots of words to say things we know already. So again, these are some things that we have to talk about whenever we talked about object-oriented programming. We talk about encapsulation, right? Encapsulation, all right, is actually one of the foundations of object orientation. And what we do here is we package the class together, and we use private and protected access modifiers for our objects and properties to house the members of the class so that it's only available within the class to hide. It's almost like information hiding, if anything else. That's what we do. Kind of say, okay, you know what? When we build our blueprint, we don't need the user of our class to know the inner workings. It's almost like, back in the day, it would become, we have a clockwork beast that we're creating, right? Somehow it moves, but, and if we give it commands, it'll follow the commands we give it, right? But we don't necessarily need to know how the clockwork works inside of it. Inheritance. So you made a class, and now you want to extend the class. You want to modify the original class because you need something else that's not included in the class itself. And you want to change some of the methods, the built-in methods that are included in the class. So you pass the class on, almost like you clone the class, and then what you do is you modify it, almost like genetic engineering in the future. You take a human and you make them a superhuman, right? Human would be your base class, superhuman, the extended class or the child class. We'll talk about that. Polymorphism, right? Polymorphism to me always refers to these when you override, you have overloaded methods, right? You have a bunch of methods, and maybe you have different signatures for those methods. Methods with only one argument, methods with 3 arguments, methods with 2 arguments. And it allows you to create multiple implementations of different methods depending on the situation for the user. A good example of that would be the message box class that we use. We instantiate the message box. When we do that, you can make it so that the message box only has a string that you're passing to it. You can pass in the string and the title. You can pass in the string, the title, and the message box buttons, an OK as an example. The string, the title, the message box buttons, and some kind of icon, right? All these things are the different signatures that you can use to overload the method of the class, which is a good example of polymorphism. I don't think, to be honest, I know that in other courses, somehow polymorphism is left for the advanced object-oriented programming. And I don't understand why that would be, because it's kind of inherent. When we talk about object orientation, we talk about it at once, right? It's kind of, you have to understand all these things. Reusable classes, of course, the whole idea, the reason why we use classes is once you make your blueprint and it works, you can create objects and reuse these classes over and over again. Whether you move when you're doing one project or when you're passing this class to another project, it doesn't really matter. You can reuse these classes with different applications. Then we're also going to talk about multi-tier applications. It's kind of a mode of programming these days, right? And we're going to talk a little bit about it. It's not necessarily different tool sets, but a mindset, right? And a methodology, a workflow that we're going to talk about more than anything else. So let's talk about encapsulation a little bit. Again, we mentioned data hiding, and we can use these public, private, and protected keywords to either expose or hide different members of the class as we see fit, as it makes sense for us to use, right? So for example, certain members, like for example the accessors, right? The property accessors, like for example the getters and setters, we want them typically to be public, right? Because we want them, that's almost like our spokespeople. If we're going to think about the class as a big company, the accessor methods, right, getters and setters, are the spokespeople of our class. Those are the things that, and especially also the methods themselves, these are the things that are allowed to be viewed by the outside world, right? Whereas our private and protected keywords allow us to have these methods or variables that are class variables that are only accessible with private. Again, it's accessible to the class, the same class, and protected is also available to subclasses. So if you want to have, for example, your variables also available to subclasses that are inherited from your base class, then that's where you use a protected keyword, and we'll see that today. Okay, so data hiding, it's all about, here's we have with one package, and we want to kind of discern or decide on which properties and methods we're going to make accessible to the outside world and which ones we're going to hide. Okay. Inheritance. So we've got here's our subclass, and here's our original base class. How do we do it? There's a bit of syntax here, and I want you guys to take a look, right? Because we're going to see this today. And you've seen this already, right? What we've seen is public partial class. We talked about this partial class idea already. We're going to talk a little bit about it more today, right? Public partial class, form 1, let's say whatever the form is, and then, but it's based off of the form base class or superclass. There's different ways of talking about this, right? So we're inheriting all the methods and properties from the form class that's built into C#. This is what this is doing here, right? And it kind of has this, when we inherit a class, it has this is-a relationship, almost like, your subclass is a subclass of the base class, right? It belongs to, it's almost like, we've taken the pattern of our base class and we've extended it. And you'll see in different other languages, you'll see the extends keyword in other languages that we don't use here, right? We actually use a bit of syntax to take care of that same extends keyword. It means the same thing though. So here's an example of a person class, right? And by the way, a person class might be a great example. We're going to talk about this about an abstract class, right? And we're going to talk about the difference in abstract classes and so on. But an abstract class is a class that you never intend ever to instantiate. So you're never going to make an object from this abstract class. Almost like it's like a blueprint of the blueprints, right? So we make a person class. He might have a name, address, and phone number, but we don't really want to extend this. We want to instantiate this class, so we create an abstract class. We'll talk about that in a bit. But we really want to instantiate this employee or a customer or a student, which is a subclass of this person class that we've created. So we've got different properties, and there's different aspects of an employee compared to a customer or a student, right? They're still people, part of the person class, right? But they're not necessarily the same, right? Polymorphism. We kind of talked about this again with overloading and overriding, right? So when you think about this overloading idea, what we want to do when we're creating a method that can be overridden, right? First, we have to specify that it can be overridden, and there's two ways to do that. One of the ways is to use the virtual keyword, which we'll see in a bit, right? So we say, okay, you know what? This particular method is virtual, which means it can be overwritten, all right? There's some that, if you make it abstract, it has to be overridden. That's a whole idea. That's a whole difference between abstract and virtual method, which we'll talk about in a bit. But what this allows us to do if we allow overriding to happen, right, what we're saying is, I want to, for example, I might have a method that allows itself to be overridden in the subclass, and I have to use a special keyword for that. One thing that you can always do is you can make an overloaded constructor of the class, right? And this is where the key is. You know, when you create your subclass based on the base class, you might have the base class constructor can have certain things it does. And what you may want to do is overload that constructor, obviously, or overwrite it, right? At the same time as making multiple methods, multiple other overloading, other methods, other constructor methods that you want to use based on the signature, different signatures to use different options when they instantiate their objects based on that class. Phew, that's crazy words, right? The idea of reusable classes, I mean, again, there's two ways of thinking about this. I can use the class in different projects, but here's another example. You have two picture box objects, picture box 1 and picture box 2. Each one has its own properties, its own visibility, its own image property, and every one of them can be set differently, right? So the idea of reusability is when I create an object, I can have different objects with the same kind of properties, but their values, once you set the values, one object doesn't affect the other one, right? They're all independent. It's almost like once you create the clone, he can have his own memory. It's not exactly like the other one. When we get into talking about multi-tier applications, we talk about more of a workflow, right? So, and you might see this more when you go into an enterprise level or a medium to large size business. They might have more structure around the way they want you to program, right? It's not enough now in one of these institutions to program well and to be good at object-oriented programming, but also run within a structure. And this is an example of one, this 3-tier application idea. You have different layers when you program. You have the presentation tier, right? Your user interface, your GUI, your forms, your controls, your menus. And then you have to pass through the business or logic tier that talk about your business rules, right? So, it talks about validation, your calculations, things that make sense of the stuff behind the forms and controls, right? So it's another tier altogether. And then there's a third tier, the data tier, which all deals with data storage and retrieval, whether it's at a database level or with files, right? Also, something to add here, because we've been using a lot of this as well, is I would put in the data tier, I would also put things like the ability to consume online content. For example, from service providers out there, right? There's different kinds of online providers, right? Web services providers, and this is where you do that. You do that in the data tier, right? So in a multi-tier application, the whole idea is to create these components that can be combined and replaced. So example would be, I have 3 students working on a project. One of them can work on the presentation tier, the GUI, right? Another one can work on the business, the logic behind it, the validation, all that stuff that affects the rules behind the GUI. And the third person can work on making these database table adapters and working with web services that they're going to consume, or storing things in SQLite if they're on a device, or on MySQL, or whatever server they're going to be using, or solution stack. And again, the idea is that you might have the same business logic, right, in an application, and you might still be using the same data logic on the other side to retrieve and store the data, and the user interface can be swapped out, as opposed to, so let's say, for example, you want to kind of refresh the user interface. You can plug in a new one. That's the whole idea behind it, right? So you have all these hooks that you can hook into the business logic layer and the data layer, but you got to go through the business logic layer to access the data layer here. How does this compare with multi-tier, like multi-tier? How do you compare multi-tier with MVC? MVC is a little bit different, right? It looks like, when we first look at the 3 tiers, it's like an MVC pattern, model, view, controller, right? But the difference is that when you have a 3-tier architecture like this one, the client tier, which is your presentation tier, never communicates directly with the data tier, which is possible with MVC, right? MVC is almost like this triangular model, and this multi-tier model is more of a linear model, right? So you have your presentation tier. So as an example here, here's an example of, if you look at this little thing here, you've got someone who's accessing and says, get sales total, right? And then it goes to the logic tier and says, get a list of all the sales made last year. Then it makes a query, which goes into the database, right? They might have some kind of information storage here, a backup, whatever it's going to happen, or even contacting other databases in another location. And then it gets the information, sends it back into the logic tier, right? And and when it gets it back, it adds all the sales together. And then what it does is it spits it out into some kind of new view that's available to the user, right? But it always has to go through these layers, in and out. That's the difference between MVC and this multi-tier application idea. Again, you know what? I see any kind of structure this way is a good structure, okay? And we have to mention it to you, and unfortunately for us, we just don't have the time to explore it in our class. I can't force you to use it, in other words, right? But I think it's a great structure to understand and use, and you might see this as you move into, like I said, more of a more structured business. That when you do any kind of application design or development, you might be forced, from a business rule perspective, and to encourage security standards and business rules, to use something like this. Okay. So let's talk about classes now. So we've talked about kind of like concepts, refreshed about what object orientation is and so on, and that should be enough. As an example, because you guys have had some kind of object-oriented training before in terms of programming, right? So you should by now have already done what? Object-oriented level 1, which is like understanding I don't know if you use Java or Python or whatever you did in your first semester when you were here, and then you should have gone into like advanced Java, which is probably what you got going on right now, right? And that should kind of cover some of the same stuff we're doing here, but in Java, right? And you should already be talking full on. Like I know that Andrew's been talking full on about object-oriented programming, and polymorphism is a big one for her. She wants to talk about polymorphism over and over again, right? But these are the things, these terms we're talking about today, you've already kind of heard, right? Now we're going to get into the syntax around C#, right? So be careful, take a look, because the syntax around C# is a little different than you've seen it in other languages, especially on the Visual Studio side. All right, so You're designing your own class. What do you need? You got to analyze what you need for the objects. You say, well, what kind of properties do I need? You know, that I'm going to define as variables, right? As an example, right? What kind of behaviors do I need when I talk about my class? What does my class need to do? So one is, how am I going to store information in my class and do that whole information hiding encapsulation bit? And the other piece is, what do I need the class to do? It's got to do something. There's got to be some kind of actions around the class. If you don't have these things, and if you never ever think about creating a subclass, don't use a class. Use a structure, right? I mean, it's a very simple. Structures and classes, and before we get into classes, are almost identical, right? You can use everything you can do with a class, you can do with a struct, right? Except for inheritance. That's one thing that the structure won't allow you to do. You can create methods with a structure. You can create properties. You can have getters and setters. You do all the same stuff that you can do with a class, but it doesn't allow you to subclass, right? So if you're not going to do subclassing, think about a structure. It's not so bad. And also, if you're not thinking about methods, like if it's not going to do anything, you're just going to use it as a data type more than anything else, the structure is the way to go. So here's your designing your own class. We want to make this book sale class, which we're going to talk about throughout this session, right? So again, we have a user form as an example that gathers unit price and quantity of a product. Here's an example, right? We can design a class that performs the calculations, right? Now, we don't have to, you don't have to use a class at all, right? We can use a bunch of methods, right, within our form class. But sometimes it's better to encapsulate that information inside a class and allow some additional functionality that we couldn't do otherwise. So what's the form going to do? Remember, when we talk about classes here, because we're talking about rapid application development, in this context, it's going to be a little bit different. If you looked it up online and understood classes, they don't normally mix it up with forms, as an example. But because we're doing rapid application development, I want to talk about how classes work with forms, which is the challenge, right? And this is where a lot of students get kind of mixed up. They go, okay, I understand classes, Tom, but how do I use the class with form? Here's how we do it. So the form is going to instantiate the class somehow, right? We're going to pass the price and the quantity through the class's property methods, as an example, right? And we're going to call a method to calculate the extended price. And we're actually going to display the extended price in the form, right? So the class is going to receive in arguments these three properties: the title, the quantity, and the price in this particular example, right? And then what it's going to do is it's going to do these private calculations in the back end, the clockwork behind the clockwork beast, the dragon that's going to be working, right? And then it's going to return the extended price into this other form field. Okay, so inside your class, you kind of define all these private member variables, right? And they store all the information that you want to encapsulate in your class, right? So we don't want to make these member variables public, because when we make them public, then we kind of break the rules of encapsulation. That's bad, right? And again, we talked about this earlier. Protected variables with a protected keyword, they look like private variables, so they're hidden from the outside world, but they're available in any class that inherits from this class. So we make a protected variable because we want to pass it along to the next class. If you just make it private, it's only available within the class itself. Okay? What we want to use is this idea of, and what supports encapsulation is this idea of these set and get accessor methods, that we want to use them, like we talked about before, to be the spokespeople to the outside world for the class. And in class methods, we can also have private class methods, right? So only accessible to the class. If you want to do a calculation or something that's available within our class that we don't really need the outside world to know about. And then the public methods are available, so that way, an example of this would be the calculate extended price method might be something that we have it as a private, it's a private method, right? We don't have to have the class access this private method, right? This to calculate the extended price. What we may want to do is access the extended price set accessor method or get accessor method to access the result, the product, which is extended price decimal, right? As an example, would be which is the product of quantity integer times price decimal. We want that. We want a get accessor method to do that, as opposed to making this calculate extended price method public. We don't need to do that. So again, we want to support the whole encapsulation. So in order for you to have a proper class, you want to use these private and public and protected keywords properly, right? That's one thing you want to do. I mentioned destructors here, but I don't expect you ever to need them, right? Because C# does a lot of its garbage collection and all that stuff on its own. It actually, makes the destructor kind of work on its own. Automatically executes. As an example, when the object is destroyed, you don't need it anymore. But the constructor is really a method that it automatically executes whenever an object is instantiated. And this is true for any object in any class in any language. It's kind of the same thing, right? So if we're building a game, okay, I'll talk about like that, and we're building it in Python, or we're building it in ActionScript for Flash, as an example. We're building a game. You're going to have this constructor, and once the class is instantiated, the object is instantiated. Like, for example, a ship. Once the ship is instantiated, it's going to have all of its properties and all of its methods. So the ship might have health, right? It might have shield strength. It might have a speed variable. All these kind of things are all parts of properties of the ship when it's constructed, when it's instantiated, right? And it also has these methods: turn right, turn left, accelerate, decelerate, right? These are all methods of the ship class that I'm talking about here, right? And it all happens as soon as it's instantiated, right? It all kind of comes together. And of course, there's other things you can do too. Like as soon as the ship is instantiated, you can make certain things happen. Like, for example, the sound of the ship's engines go, right? As soon as the ship appears, or an alien object, if you're making an alien class, comes into reality, right? Once it's created, it has all the methods and properties that exist within other classes of the same type. So what we want to do, we talked about this idea of polymorphism, and one of the main things here is we want to overload many times the constructor, right? And how we do that is we create different argument signatures, right? So it's the list of argument in the right order, as an example. So here's two constructors. The first one here, where it says public clothing sale, and again, your constructors should be public, guys. If you don't make them public, then you can't, do anything. We can't instantiate anything, right? And the constructor takes the same name as the class itself. So, for example, if the class is called spaceship, then the constructor is also called spaceship. The constructor method is the same name as a class, right? And then you have two different methods here. One that's an empty constructor, so I'm not taking any arguments, and another one that takes three arguments: a string, an integer, and a decimal. So these are two different signatures, and the user of this class has both those options. He can do, he can create this empty constructor idea, and you can also use this a constructor with multiple arguments. So here's an idea. When we talked about a parameterized constructor, right? It talks about a constructor that requires arguments. So this is where I need arguments. I'm not going to make the empty constructor as an example. And what I want to do is it's funny how it works. You want to use these set accessor methods that you write ahead of time, or they're part of your class, right? Now, I typically, when I write my classes, I write all my properties methods at the top of the class. That's just the way I do it, right? And in the top of my class, I also write these getters and setters before I write my constructor. That's just the way I do it, all right? Everyone's different. You don't have to do it that way. In fact, as long as it's within the class, it'll be accessible to the constructor. You don't have to write. The order isn't important, okay? The compiler, as it goes through and it builds your code, it'll put everything in the right order anyway, so it's all accessible. But at the end of the day, what I do is, from a logic perspective, I'd like to build all the things that I need inside my constructor before I actually call my constructor, right? Just from a logic perspective. So here's a constructor clothing sale, and it takes string, an integer, and a decimal. And then when I take these things in, I want to use the set accessor that I've kind of already described. So I might have something called a product number as a set accessor method that I've defined with the set keyword, right? And I want to say my product number is equal to my product number string. So I actually use the set accessor methodology as opposed to the private member variables, all right? Because you don't have to use the private member variables. You can use your set accessors if you've already defined them, and this is the right way to do it. And when I say right way, it's the established methodology, okay? I also have a method that does something, calculate extended price. And again, because I'm using it in my constructor, my gut feeling says, just because from old programming practice, it should be already kind of defined. What is this calculate extended price? So I put that before I put my constructor, just from a programming perspective. You don't have to. You can put it after as well, like I said. I like to make it before because I want to be able to call something that's already been created. It's habits. So let's do this together. There's a couple of ways to do this class stuff, and I've talked a little bit about it, but I want to kind of get into the nitty-gritty because there's some nuances when we do it within Visual Studio that it looks easy, but it's not necessarily so. So let's do that by going straight into Visual Studio. So here I am back in Windows 8, and I'm going to create a new project. So hopefully you guys are following along with me. New project, right? And I'm going to call this lesson 12, and it'll be called the class demo. I could call it OOP demo, which may make sense as well. How about that? Okay. I'm going to make it a Windows form application right now, right? I'm going to press OK. It creates my basic form, right, as an example. What I want to do to prepare for what I'm going to do later on is I want to rename this form base form. Okay, we're going to just follow along with me here. I'm just going to kind of make this form up a little bit. So here's base form, right? And yes, I want to accept that. I want my base form, just again, from some refresh, I want this to start kind of in the center of the screen. So here I am, it's in the center of the screen. And I want to change my text, my base form to base form for now. Okay? Again, I can do whatever I want with it from here. I want to add a class to my form now, and my class is going to be this book sale class. If you go back to our presentation, right, I'm going to add a class, and there's different ways of doing it, right? So I can do, from the project menu, I can say add new item, right? So I can go to the project menu. This is one way of doing it. So project, add new item. And in there, it's going to give you a bunch of different things. One of them is class. That's one way of doing it right there, okay? By the way, I don't have to make it this in a separate file. I could create the class inside my form, the same class that's included in my form. I can include it there too, if I really want to, right? But it's much cleaner and better if you do it separately like this. Or it's an option number 2. I right-click on the actual the project itself, right? And I go to add, and I go class, because it's right there as an option. I like this option the best because I don't have to swim around the project menu and so on. So I click, new class. Now it brings up this same dialog box anyway, and I want to kind of call the class book sale, right? So let's just do that. We'll call it the book sale class down here, and it's a good place to kind of write the name of the class, book sale. Has to have a .cs extension. Okay, and if you notice, there's a bunch of other things you can do here as well. Component class and so on. We just want the class, right? And then click add. Once you've done that, what does C# do with Visual Studio? It kind of puts together some using statements at the top of your class, right here. The basic stuff. It includes system, the collections, link, text, and threading, and so on. And you can add others that you need. If you're going to do, for example, file handling, you probably put the system.io using statement in there as well. The namespace, it still has the same namespace. This is important because if I was going to reuse this class in another project, I'd have to change my namespace. But right now, my namespace is lesson 12 _ OOP demo, which is the name of my project, right? And here's my class statement, book sale, right? So this is the first part. Inside this code block is where I define my class. Okay, I got to give myself some space, right? So here I am, giving myself a little bit of space in the actual class itself. The other thing that's really good to do when you're creating a new class is do some documentation, guys. Like I know some of you are bad at this, right? Or don't care about it, or think it's unnecessary, right? But really, it's not a bad thing. It takes 2 seconds to kind of space down and go to the top. And I know we're kind of, oh, I made a mistake, by the way. Let's fix that. Doop. I kind of erased system for some reason. I don't know why I would do such a crazy thing. But anyways. So there's 2 ways to write comments again. You can do the // and it becomes green in Visual Studio, or the way I like to do it as well is kind of the /*, which kind of allows you to do multi line comments here. So I'm starting off and I say, program. I can say the program is called, lesson 12. And then it's an object-oriented demo, right? That's what we're doing here. Maybe give myself a little bit more space in the comments, right? I skip down and I go to programmer. Well, that's me, right? Or you, if you're doing it. So Tom, and then date. Why am I doing this? Because I know some of you won't do this kind of stuff on the exam, and you need to, right, to get some marks. The dates, today's date, well, let's put November, right? We don't really care exactly the date, but in your particular example, you probably want to put in the exact date, right? And then, kind of a description. So, and I'll put in here the book sale class. Okay, you can put whatever you like in there. I'm just giving you some basics, and then you're gonna kind of end off your comments with another */, right? And that kind of gives you your multi-line comments. Very, very simple, clean. And it actually, if you notice, every time I kind of press enter, it added this star in there for you. I didn't do that on my own. I didn't do that separately. It just kind of does it for you, which is kind of cool. So if you wanted to create like multiple, like a little box, it supports that whole idea. This is enough for me. So I've kind of documented what this is. And what's the first thing I'm going to do within my class? Well, I know that I'm going to probably need to put in some class variables right at the top, right? So I'm going to kind of put in here a comment that says, class variables, class level variables, just like I do with my form classes that we've been seeing before. So I don't know what it's going to be yet, but that's what I need. So I'm kind of creating my class. I'll save everything right now, right? And kind of go back. So I've kind of done this already. So we need a couple of these, these different variables here. What I want to have is, if you notice, each of these, they're private. The string, title string, quantity integer, and a couple of decimals, the price decimal and the extended price decimal. All these things I need to kind of include in my class. Now I'm a little bit lazy. Oops. So I'm going to kind of go into the presentation and copy and paste. That's the kind of guy that I am, right? Because I don't feel like typing unless I have to. So I'm going to copy and go back, and then right here and under this area here where it says class level variables, I'm going to kind of say paste. Right, so there they are, right? So I've kind of, it's almost like a code snippet when you watch a tutorial, right? So here I've got my, my class level variables here that I define, and if you notice, each of them is private because I want to support the idea of encapsulation. I don't need my variables, my class variables, to be public so that I can see them in the outside world, because the outside world doesn't need to see these variables. They're just for my class. All right. The next thing I want to do is I want to kind of put it together all my methods, my accessor methods. And again, my accessor methods have to be all public. And this is kind of a review of what we showed you in that addendum a few lessons ago when we talked about getters and setters, right? And passing data along from one form to the other, right? So what I want to do is I want to start typing this public string and the title, whatever that'll be the title string, and I want to kind of add in my getters and my setters in here, right? So the get accessor method and the set accessor method. And I'm going to do this again before I talk about my constructor, okay? So here's my title. So here I go. So I'm going to put in a comment that says accessor methods. Okay? I'm doing this because I want to be able to separate the difference between class level variables and accessor methods that are available to the outside world. Right? And again, I start typing public string, the data type, and the title would be the type of the name of my accessor method. I want to put create a code block by using my curly braces, and inside there, oops, if I can actually fix that, inside there, one more time. I don't know why it's doing that to me today. Don't do that. Inside there, what I want to do is I want to put the set method, right? And by the way, there's quick ways of doing this, but we're not going to go into that. So here's my set method. I want to kind of outline my set method. Let's scroll down here a little bit. And my empty get method, right? So again, what does my set method do compared to my get method? People are confused about these things, right? Well, my set method sets the private member variable that's associated with this accessor method. So my public title variable that's available to the outside world, my set accessor method sets it, right? So I might have to put title string in there, right? Makes sense that I would set it. And it's going to set it to the value that I associate, that I assign it. So in here, I'm going to put in title string, right? So here's my title string, equals to, and I'm going to use the value keyword. This is just a review for those people who've forgotten how to do this, right? And that basically says that whatever value I assign to my set accessor method, it's going to be passed into my title string, which is the private member variable part of my class. Okay? Then on the get side, I need to have a return statement, right? That's why it's giving me that squiggly underline, because the get accessor method has to pass information out of the class when I'm asking for it, right? So I can use the same variable name, title, and I can say, as an example, booksale.title. I want to get the booksale.title. So maybe I want to assign booksale.title to a text box. So maybe I have a title text box. So title text box is equal to booksale.title. That's using the get accessor method, right? So I'm getting that information, returning it back out. So I'm going to say return, right? Here's my return. And I'm going to return title string this time, right? So that passes it back outside. And if you notice, the squiggly line goes away. This is the right way. So this is both the set accessor methods. So I'm just going to put a little comment in there, right? So set accessor method. I'll just do this for the first one. And here's the get accessor method. Both of these are also called setters and getters. You're going to see that later on. I got to do kind of the same thing for all my other properties that I want available to the outside world, right? So I've kind of done it for done it for title. My guess is probably I'm going to have to do it for quantity, price, and extended price. Let's take a look. So here's my title. Here's my quantity. Now this is interesting. Here's an example where I can only set the quantity, but I can't get the quantity, right? What is this called? It's a write-only method, right? Set accessor. I don't have a get accessor here. So it means I can't do the other way around. I can't say, well, give me the quantity back once I've set it. It won't allow me, the class, this methodology will not allow me to get it back. It's a write-only methodology for writing this accessor method, right? And if you notice, what I'm doing here is I'm saying if my value, so I'm looking at my value keyword, if it's greater than or equal to 0, only then do we want the quantity integer to equal to the value. Why? Anybody? Because if I have a weird number, something weird that's in here, right? And I try and set it, it can crash my code, right? If the user puts in some other weird value. Now it shouldn't, right? But sometimes we're taking information right from, and it's kind of another level of validation for us. We should be validating right at the form field, right? That's the first level of validation. And here's the second level of validation saying if it's not greater than or equal to 0, then we don't want to set it, right? So let's do that again. So I'm going back to my code, and again, I'm setting the quantity. I'm going to go down. I'm still inside my class. I'm still inside the accessor methods section, right? Oops, but I actually try to include it in here into my. I'm actually including it inside my my string accessor or my title accessor method, which I don't need to. I'm going to skip down here to a new line, right? And kind of tab across. I'm going to say public, and then now the integer, it's a quantity integer, so it's going to be an int, and I'm going to put in the name of the accessor method. And remember, these names that are public should be friendly names that are going to be used. You're not going to put in quantity int, right? That's for internal use. That's for us, right? And here we're going to just define a setter, because we're going to make a write-only setter here. And inside the setter method, we're going to make an if statement. So if, right, value, right, is greater than or equal to 0, then inside the if statement, we're going to put in that the quantity integer is equal to the value that we're going to get from the set accessor method. Okay. So that's our write only, and we'll put that in there, right? Write only set accessor method, right? Because we want to be able to only write once, write to the class, but not get anything from the class. Similarly, right, we want to do the same thing for our price decimal, right? We don't want, once we've sent the information to the class for price decimal, quantity, price, right, as an example, we don't want to get anything from the price decimal. We just want to set the price decimal, and we want this same idea here. We wanted to check the value is greater than or equal to 0. Again, validation on your form should be written so that you don't have that issue. But this is another level of validation. So again, public, right, and then decimal price. And we're going to write this other setter method, just like we did before, right? Here we are. And in here, we're going to put in if value is greater than or equal to 0. And now you don't have to do this, like I said. It's just another level of validation. Then price decimal, which is our private member variable, is equal to value, right? And again, here it's a write only, if I can spell this properly, set accessor method. Okay, there we go. And I'm going to scroll up. So we've got kind of written a couple of accessors, right? We have our a few of them now. We have our title, our quantity, and our price, right? Next thing we need to do when we go back, we need to talk about this extended price. And if you notice, this doesn't have a set accessor method because we shouldn't be able to set the extended price. The extended price has to be calculated. So now we're going to define a read-only method. This is a good example of a read-only method. We're just getting information from the class, right? As opposed to just setting and getting, right? Oops, that's not what I wanted to do. So here we go back here. And I'll fix that now after I've somehow destroyed it. Public, right? It's got to be a decimal, right? And it's extended price. So I want to get the extended price, right? I got to call it extended price. And again, I'm going to create my code block, and this time I'll just use a get accessor method, making it read only, and then from here I want to return the extended price decimal that I'm going to be calculating, right? Okay, and again, this would be a read only get accessor method. Okay, because in other words, there is no set paired with this one. It's just a get, And the reason why is because we want to get the extended price. We never want to be able to set it. We want the class to calculate it for us. Okay, so now we want to create our constructor, right? But if you notice, there's something that's in here, calculate extended price, that I feel uncomfortable writing. I wouldn't want to write it this way yet. I want to kind of create that calculated extended price method before I use my constructor. That's just me, right? Now again, you can put this wherever you like, but I hate when the little squiggly red line comes up because it's not going to know what the extended price, calculated extended price is when you create your constructor. So I'm going to skip forward for a second to this calculated extended price slide, right? And I'm going to do this first. So I'm going to say, make a private method, right? That's called calculated extended price, and it's going to say extended price decimal is equal to quantity integer times price decimal. So let's do that. So now we've done our methods, and now I'm going to put in here private methods section, right? Because that's our accessor methods. Here's our private method. So private, and the extended price is going to return what? A decimal, right? So I need to have decimal in here, right? And it's called calculate extended price, right? That's what our method's going to do, right? If you notice, I'm going to it's giving me this error because it says not all code paths return a value because I haven't put a return statement in there. Well, my return statement is going to be return, right? Extended price decimal, here it is, right? That's what it's going to return, is equal to price decimal times quantity, right? Quantity integer, right? That's what it should do, if I'm not wrong. And that's just to confirm that I'm not imagining things. So it's the other way around. But at the end of the day, it kind of does the same thing. So my price times my quantity, or my quantity times my price, and this is what it's going to return. It's going to return, and some comments, returns the extended price. So this, to me, now I have all my requirements to write my constructor. I've got all my set accessors, or my accessor methods, or my properties, if you will. And now I also have my private method that I'm going to include with my constructor, right? And I've written it above my constructor because I feel comfortable doing that. You don't have to, but that's how I've done it, right? And now I'm going to write my constructor statement. If I don't write a constructor statement, the default one is going to be the empty constructor that's going to be available to the outside world. It's already written for me. I don't have to override it, all right? Because remember, class, when I use the class keyword, it automatically inherits the object base class, right? So it has some already things it's inheriting, right? And one of them is the empty constructor method. So here's my constructor method. I'm going to put that in there, constructor method. Okay, and now, again, it has to be public. That's the first thing, because it's a constructor method, right? Does my constructor method return anything? No, right? But I don't have to put the void keyword in here, all right? Because it's a constructor method. It's got to be the same name as my my class. So it's going to use book sale as the name. And then I'm going to have to define what I'm listening for, right? What I want to kind of take in, right? So if I go back to my, just to keep on line with what I'm doing here, I need to take in the title, the quantity, and the price, right? I want to take those in. And if you notice, sorry. So here's my string. So first I'm going to take in my title. So here, again, I recommend to you not to use the the same variable names, because you can. Be careful what you do here. So they're a little bit different, because otherwise you'll mess up, right? You want them to be a little different. So you can say something like when book sale title, right? That's perfectly fine. So that's the book sale title. You're getting the book sale title, whatever that is, right? I'm making it different because I want to make sure that I understand that the arguments that I'm taking into my constructor are different than the variable names that I have as private member variables and the accessor methods that I'm using. So string, and again, is it price or quantity and price? I can't remember. It's quantity and price. quantity is int. So book sale, this is me, book sale quantity. Right, this is what I would do. And decimal, right, is book sale price. So those are the three arguments, if you will, that I need. Now I'm going to kind of put my braces in place. So I'm ready to go with my my code block. Okay, and this is a good example of a parameterized constructor, right, where I'm going to use the names of my extended price, my price, and so on. All these things up here, right? Here we are. In my constructor, I'm going to use my title. I'm going to use my quantity, and I'm going to use my price because all these methods have set accessor methods built into them. So I'm going to use them as opposed to using my my private member variables. I could use my private member variables here too because they're available to my constructor, but I'm not going to do that. I'm going to use my set accessor methods. So I'm going to say title, right, which is a set accessor method, is equal to book sale title, right? Because I'm kind of taking that into my constructor, right? I'm going to say quantity, right? And that's, again, this is the set accessor, is equal to book sale quantity, right? And price, here it is, my accessor, is equal to book sale price, which I'm going to get from my constructor. So I've kind of taken in those things, and now I'm assigned those they kind of pass through my set accessor methods into my private member variables.
So it's kind of automatic, like it automatically sees that there's a setter there, so it's going to...
That's right. That's why I've made my setters first. I create my setters, then all my private methods that I need in my constructor, and then I put my constructor together. That's me, right? Everyone can do it differently. You don't have to do it that way. I just don't like the squiggly lines, right? Which they'll go away anyway once you create them. But that's just me. It's a pet peeve, okay? Yeah. Then I'm gonna call my private method that's only available within my class. It's called calculate extended price, right? And what that's going to do is going to take my title, my quantity, my price, right? And it's going to calculate my quantity, my price, and create using the extended price set accessor. It's going to set that, okay? That's done. So now I've created my constructor. So I've got everything that I need pretty much for my class. I'm going to save everything. One thing you can do here with Visual Studio is you can build, as opposed to how we did it before, without running. I'm going to build my solution now, right? Because I want basically to instantiate kind of build my class for the first time. I haven't instantiated yet because my form doesn't have any elements that are going to need it right now, right? Let's go back. So, kind of step forward. So I've up to this point, I've kind of in my examples here, as we're going live, I've created my class, but I have yet to instantiate my class, which we're going to talk about, or even use it at all within my form. So let's take a quick break, and then when we come back from break, we'll go and do the next part of it.